Hello everyone, I am Hussein and welcome to Pragmatic Programming channel. In this video, I'm going to talk about boxing and unboxing and how do they work. Now assume that we have a variable of type int, let's call it num. I will value it as a 46, and now we have another variable called object num obj. Now if I just write num in here, and now I'm assigning num, which is an integer variable, into a num object, which is an object type. As you remember from our previous video, this variable int num is actually stored on stack, not on heap. But this one, object, is stored on heap. When I'm doing this, I'm implicitly saying that copy the value of number variable into the num object on the heap. Doing so is called boxing, because we are boxing the value of num variable into the heap, which is referenced by the num object. And the reverse of doing this is called unboxing, which I will show you. Int num2 assigned by num object. But it's not gonna work this way, because you should explicitly specify what type does it contain, which is int. This one that I'm highlighting is called unboxing. Now I want to show you how memory is allocated once we're doing this. So I will put the breakpoint here, and now I'm going to start the debugging. Now that we are here, I want to take a snapshot. Now I will continue one line in here. I want to take another snapshot. You can see there are some differences. As you can see, an object type called int32 is added to the heap, which has about 24 bytes of data. And if we go, we can see the value that is stored on our RAM. It's 46, which it was not there before we passed this line of code. Now we're going to pass this line of code and now take another snapshot. As you can see, it didn't change anything, and we can find our int32 object right here, that it is still there. Okay, now I have prepared a benchmark to show you how does the boxing and unboxing will affect you. Let me change to my benchmark and change the building to release. Now let's run this. Now here are the results. As you can see, the boxing benchmark took us about 24 bytes of data, and it took about 2 nanoseconds. And for unboxing benchmark, it took about half of a nanosecond, and no allocation. I've added a simple primitive return and simple object return to see how much calling of my methods are actually taking, to subtract it from the values that I'm seeing here in C, and you can see that it took almost nothing. And there's another tip that I'm gonna share with you, is that once you are using the ArrayList new ArrayList, and let's say add num, this code is still boxing, because inside of our array list we have an array of objects that when we say add num, it will box it to that object. By doing so, we are wasting a lot of performance and memory. So what can we do about this? Well, we can simply use generic things like, let's say, list new list of the int, and then let's say list.add the number. So as you can see, the generics are solving our problem. But what is generic and how do they really work? That's what we will learn in our near future episodes. So stay tuned. Well, that's it for today. I hope you enjoyed this video. Leave a like if you like this video, and subscribe to my channel and hit the bell so you will be notified once I publish my next video. Thank you.